Hi, welcome to the 8th section of the course, Pointers, the Standard Template Library, and Texture Management. In this section, we will learn about pointers, learn about the STL, implements the texture holder class using static functions and a singleton class, implement a pointer to a horde of zombies, edit some existing code to use the texture holder class for the player and the background. Now we move on to the first video of this section, getting started with pointers. In this video, we are going to take a look at pointer syntax, declaring and initializing the pointer, reinitializing the pointer, and dereferencing a pointer. Pointers can be the cause of frustration while learning to code C++. Actually, however, the concept is simple. A pointer is a variable that holds a memory address. That's it. Nothing there to get concerned about. What probably causes the frustration to beginners is the syntax, the code we use to handle pointers. With this in mind, we will step through each part of the code for using pointers. You can then begin the ongoing process of mastering them. In this section, we will actually learn more about pointers than we need for this project. In the next project, we will make greater use of pointers. Despite this, we will only scratch the surface of the topic. Further study is definitely recommended, and we will talk more about that later. Rarely do I suggest that memorizing facts, figures, or syntax is the best way to learn. However, memorizing the fairly brief but crucial syntax related to pointers might be worthwhile. This is so that it sinks so deep into our brains we can never forget it. We can then talk about why we need pointers and examine their relationship to references. A pointer analogy might help. If a variable is a house and its contents are the value it holds, then a pointer is the address of the house. We learned earlier that when we pass values to or return values from a function, we are actually making a completely new house, the exact same way as the previous one. We are making a copy of the value passed to or from a function. At this point, pointers are probably starting to sound a bit like references. That's because they are a bit like references. Pointers, however, are much more flexible, powerful, and have their own special and unique uses. These special and unique uses require a special and unique syntax. Pointer syntax. There are two main operators associated with pointers. The first is the address of operator, denoted by ampersand, and the second is the dereference operator, denoted by asterisk. We will take a look now at the different ways we use these operators with pointers. The first thing you will notice is that the address of the operator is the same as the reference operator. To add to the woes of an aspiring C++ game programmer, the operators do different things in different contexts. Knowing this from the outset is valuable. If you are starting at some code involving pointers, and it seems like you are going mad, know this: you are perfectly sane. You just need to look at the detail of the context. Now you know that if something isn't clear and immediately obvious, it is not your fault. Pointers are not clear and immediately obvious, but looking carefully at the context will reveal what is going on. We can now start to actually see some real pointer code. Declaring a pointer. To declare a new pointer, we use the dereference operator along with the type of variable the pointer will be holding the address of. Take a look at the code, and we will go into it some more. This code declares a new pointer called pHealth that can hold the address of a variable of type int. Notice I said can hold a variable of type int. As with other variables, a pointer also needs to be initialized with a value to make proper use of it. The name pHealth, as with other variables, is arbitrary. It is common practice to prefix the names of variables that are pointers with a p. It is then much easier to remember when we are dealing with a pointer and to distinguish them from regular variables. The white space used around the dereference operator is optional, because C++ rarely cares about spaces in syntax, but recommended, because it aids readability. Take a look at these lines of code, which do exactly the same thing. This format we have just seen in the previous example with the dereference operator next to the type. White space either side of the dereference operator. The dereference operator next to the name of the pointer. It is worth being aware of these possibilities so that when you read code, perhaps on the web, you will understand they are all the same. In this course, we will always use the first option with the dereference operator next to the type. Just like a regular variable can only successfully contain data of the appropriate type, a pointer should only hold the address of a variable of the appropriate type. A pointer to type int should not hold the address of a string, zombie, player, sprite, float, or any other type. Next, we can see how to get the address of a variable into a pointer. Take a look at this code. In the previous code, we declare an int variable called health and initialize it to 5. It makes sense, although we have never discussed it before, that this variable must be somewhere in our computer's memory. It must have a memory address. We can access this address using the address of operator. Look closely at the last line of the code. We initialize pHealth with the address of health, like this. Our pHealth now holds the address of the regular int health. In C++ terminology, we say that pHealth points to health. We can use pHealth by passing it to a function, so the function can work on health, just like we did with references. There will be no reason for pointers if that was all we were going to do with them. Let's take a look at reinitializing pointers. A pointer, unlike a reference, can be reinitialized to point to a different address. Take a look at this code. Now pHealth points to the int variable score. Of course, the name of pointer pHealth is now slightly ambiguous and should perhaps have been called pint pointer. The key thing to understand here is that we can do this reassignment. At this stage, we haven't actually used a pointer for anything other than simply pointing. Let's see how we can access the value stored at the address pointed to by a pointer. This will make them genuinely useful. So we know that a pointer holds an address in memory. If we were to output this address in our game, perhaps in our HUD, after it has been declared and initialized, it might look something like this, 9876. It is just a value that represents an address in memory. On different operating systems and hardware types, the range of these values will vary. In the context of this course, we never need to manipulate an address directly. We only care what the value stored at the address that is pointed to is. The actual address used by variables are determined when the game is executed at runtime, and therefore there is no way of knowing the address of variable and hence the value stored in a pointer while we are coding the game. We access the value stored at the address pointed to by a pointer by using the dereference operator. This code manipulates some variables directly and by using a pointer. Try and follow along and then we will go through it. Warning: the code that follows is pointless. It just demonstrates using pointers. In this code, we declare two int variables, score and high score. We then initialize them with the value score equal to 0 and high score equals to 10 respectively. We next declare two pointers to int. They are pint pointer1 and pint pointer2. We initialize them in the same steps as declaring them to hold the addresses of the variable score and high score respectively. Next we add 10 to score in the usual way, that is score plus equal to 10. Then we see that by using the dereference operator on a pointer, we can access the value stored at the address they point to. This code actually changed the value stored by the variable pointed to by pint pointer1. The last part dereferences both of the pointers to assign the value pointed to by pint pointer1 as the value pointed to by pint pointer2. Both score and high score are now equal to 20. In this video, we have looked at getting started with pointers. Cool! Next we'll take a look at working with pointers.